Hello everybody, welcome back. This is Mr. Strager. Today we're going to be talking about section 2.4 in our Big Ideas Student Journal. Now this section can be found on page 45, and you might notice something interesting about it. It's entirely blank. There's no vocabulary, there's no notes really. This is because with this section, everything that we need to know, we already know from Unit 1. There's nothing new to be taught here. It's just a matter of applying what we already know to the new unit. Let me give you an example. Let's say I had the following equation from Unit 1. What I want to do is I'm going to split my page for the notes down the middle, and I'm splitting it into Unit 1 and Unit 2. I'd like you to do the same. This is a problem that we might see in Unit 1. How do we transform this into something we'd see in Unit 2? Well, instead of it being an equal sign, there just needs to be an inequality symbol. So this is what we have here. We have two problems that look very similar. For section 2.4, our goal is to solve multi-step equations. Equations that, well, might take more than one thing you need to do. In the past, with section 2 or with Unit 2, we've only had to add or subtract something from both sides, or multiply or divide something from both sides. With this one, we have multiple things we need to get rid of. So let's take a look at the Unit 1 version of the problem. 2x minus 3 equals 5. If we take a look at this problem a little more closely, what are we trying to get by itself? Well, our goal is always to get our variable by itself. That's when we have a solution in Unit 1. So we want to get this x all alone. Okay, well, what's preventing it from being by itself? There are two things that are attached to our variable here. Our 2 is attached to our x, and our 3 is attached. How is our 2 attached? Well, since we have a number right before a variable, that means that these two things are being multiplied together. So it's 2 times x. How is the 3 attached? Well, this one's a little more visible. We can see the subtraction sign in between them. Here's the thing. Whenever we have multiple things to get rid of in a problem, it's super important that we pay attention to the steps we need to do. It's super important that we know what order to get rid of things in. That order is given to us by reverse PEMDAS. As a reminder, when I say reverse PEMDAS, what I mean is this. We start from the bottom, and we get rid of anything that has to do with addition and subtraction. Then we get rid of any multiplication and division, then we get rid of any exponents, and then we get rid of any parentheses. So, is there any addition or subtraction in the problem we can get rid of first? Well, yes, we identify that we're subtracting 3. How do we get rid of subtracting 3? This is where we would need to do the opposite. The opposite of minus 3 is plus 3. But we can't just do it to one side. We have to do it to both sides of our equal sign. These two will cancel out because negative 3 plus 3 is 0. That means we're just left with 2x over here. And 5 plus 3 is 8. But we're not quite done yet, because our x is not by itself. It's closer. We mentioned that 2 and x are being multiplied together. And it turns out that's the next step for our PEMDAS. We have to do multiplication and division. So how do I get rid of multiplying by 2? Well, if you remember all the way back in Unit 1, we would divide by 2. These two will cancel out, leaving us with just x equals 8 divided by 2, which is 4. Nothing new. We talked about this in Unit 1. But if I take a look at this problem here in Unit 2, I mentioned that we have everything we need to solve this problem. What I mean by that is this. The steps to solve these problems are the same in both units. There's no difference. The only difference is this symbol. And we know how to deal with this symbol. We know to keep it the same throughout, unless we're multiplying or dividing by a negative number. So we're going to follow the exact same steps we did over here. What was the first thing we did? We added 3 to both sides of our, here was an equal sign, here we're adding it to both sides of our inequality symbol. So that'll give us 2x is greater than 8. I'm keeping it as a greater than symbol because we didn't multiply or divide by a negative. Okay, well how do we get rid of the 2? Well, over here we divided by 2 on both sides, so let's divide by 2 here. Do we need to flip our sign? Well, no. Even though we're dividing, we're not dividing by a negative. The rule is if you multiply or divide by a negative, then we have to flip our sign. So these 2's cancel out, leaving us with just x. Our greater than symbol sticks around, and 8 divided by 2 is 4. So these are our answers. X is equal to 4 when we have an equal sign, and x is greater than 4 when we have a greater than sign. I wanted to show this because it shows how these two units are incredibly alike. In class, we did, however, do one more problem, and this one was a little bit trickier. So continuing down with your split page, I'm going to have to make a new page because I want to make sure there's enough room. Continuing down with your split page, underneath the Unit 1 side, I want us to write out the following problem. I want us to write out 8b minus 3 is equal to 4 times 2b plus 3. On the Unit 2 side, it is going to be almost the exact same problem, except instead of an equal sign, we are going to have a less than or equal to symbol placed here. What I want you to do is this. I want you to try this problem out by pausing the video and see how far you can get. If you can get all the way through the left side, try the right side. The steps will be the exact same. If not, don't worry. You can unpause the video and check your progress. Just keep pausing it and trying to finish it before I do. All right. Let's get started to see how we can tackle this problem. First things first. We should notice there are variables on both sides of our equation. When you have variables on two different sides, your goal should be to bring them to the same side. But we have a problem. This 2b term is locked inside of these parentheses. What that means is, unfortunately, we can't just move it over. We need to get it out of the parentheses first. Well, how do we do that? The key is this 4 outside of the parentheses. Anytime you have a number outside of parentheses, it means you can multiply it to everything in the parentheses. So 4 times 2b is 8b. 4 times 3 is positive 12. So we're left with 8b minus 3 equals 8b plus 12. From here, there's kind of two ways to do this problem. You can either start off by getting all of your whole numbers on the same side, or getting your variables on the same side. If you wanted to get your whole numbers on the same side, you could either add 3 to both sides or subtract 12. Either way, you'll end up with the same answer. But instead of doing that, I want to show the other way, by getting our variables on the same side. Let's say, theoretically, that I wanted to move my 8b from here to here. How could I get rid of 8b? Can't divide by 8, because unfortunately we still have this plus 12 here. I can't divide by 8b. Again, that'd be dividing the 12 by 8b. But I can subtract. What should I subtract from 8b to cancel it out? Well, 8b minus 8b, those two will cancel out because they make 0. So that'll allow me to move my variables over to this side. But you may have noticed something interesting about this problem. When we move it over, 8b minus 8b, these will also cancel out. Well, what are we left with in this case? We're left with negative 3 equals 12. Now, this should kind of ring a bell here, but do we remember what happens when we end up with an answer that's complete nonsense? If you end up with a statement that is just false and complete nonsense, we say that it has no solution. No solution, because there is no way that negative 3 will ever make 12. Now, if our answer was something that makes perfect sense, like 12 equals 12, well then we would have all solutions, because it's true. Anytime you have a false statement, it's no solution. Anytime you have a true statement, it's all solutions. And anytime that you still have a variable around, like b equals 2, well then that's just your solution right there. Let's apply what we just did to this side as well. Remember, the steps are going to be the exact same no matter the unit. So, on the left we distributed, let's try distributing here. Again, we end up with something very similar. 8b minus 3 is less than or equal to 8b plus 12. From here, our goal is still the same. We still want to get all of our variables on one side. So I'm going to subtract 8b from here to cancel it out and move it over here. But when I moved it over, 8b minus 8b also cancels out. So I end up with negative 3 is less than or equal to 12. So surely the answer should be the same too, right? Well, hold on. Remember what I said. You have to decide if the statement is true, false, or just a normal solution. In this case, we are left with the statement 3 is less than or equal to 12. Is that true or false? If somebody walked up to you and said, hey, negative 3 is less than or equal to 12, would you call him a liar, or would you say he's true? This one is true. Negative 3 is less than or equal to 12. It's less than. So we would say that this one has all solutions. Isn't that weird how it works out? The key is this. The way you solve your problems is going to be the exact same in both units. The difference comes with what you do with your answer. Thank you so much, everybody. Remember, if you have any questions, feel free to reach out. Otherwise, have a fantastic day.